Okay, this is going to be part 4 of the video series on trigonometric integrals that involve sine and cosine. Now, in the first 3 videos, we looked at problems in which the power of the sine was odd, and we also looked at powers where the cosine was odd, but they were all in this form right here, the sine raised to a power times the cosine raised to a power. What we're going to look at in this video is this third option down here. Suppose rather than having the powers to an odd power, suppose they are to an even power. Now in that case, you'll use these 2 additional formulas down here. And what these are, you might remember them from your trig days. They're the half angle identity formulas. So the sine squared is equal to this, the cosine squared is equal to this. But remember, if you have the angle x on this side, then you'll have 2x over here. So if you have x over here, you'll have 2x over here. So these are known, again, half angle identities. And this is what you'll use to solve these problems. So you don't have to worry in this case about necessarily factoring one thing out or so on. So anyway, let's take a look at a couple of problems here. We'll look at one of them that involves the sine, and we'll look at a second one that involves the cosine. Okay, now on this first problem, what you've got is this. You want to find the integral of the sine squared of x. Now the sine is raised to an even power, and there is no odd power in here, so this would fit in this third definition. The powers, the sine and cosine, are both even, or perhaps one of them doesn't exist. Now you've got the sine squared, so we'll wind up using this identity right here. So the idea is starting with this. Now again, let's just put the identity back up where you can see it. But the identity would be this. The sine squared of x is equal to 1/2 of 1 minus the cosine of 2x. And we'll just actually take off with that formula as we run through this. So again, you've got a sine squared. Now there's no cosine on this one, so just go ahead and your initial step is just going to make this be the integral of, and change this into this. So this would be 1/2 of, and then you'll have 1 minus the cosine of 2x. And you've got dx right here. So your very first step is to just change it from the sine squared form into the sine of 2x, and that gets rid of that squaring. Okay, the next thing you can do, you can go ahead and bring this 1/2 out to the front. So we'll make this be 1/2 of the integral of 1 minus the cosine of 2x dx. Now at this point, it's just a matter of splitting it up into 2 separate integrals. You can find the antiderivative of 1, and you can find the antiderivative of the cosine. So we'll go ahead and split this up into the following. Make it be 1/2 of the integral. And actually, I think I'll put this in brackets here. So first of all, we'll find the integral of 1 dx minus the integral of the cosine of 2x dx. So the idea is split this single integral up into 2 separate integrals, and you can work with each one of those separately. Now, on this one, you will not need use substitution, but on this one, you will need use substitution. So what we'll have here would look like this. So this is going to be 1/2 of, now we'll go ahead and do this one first. The integral of 1 would just turn into an x. Then you're going to have minus. Now in this one, though, you're going to have to use substitution because you've got something more complicated than just a simple x in here, so that's going to be your choice of u. So let's go ahead and do the u substitution over here. So in this case, u would be equal to 2x. So the derivative of u with respect to x would be equal to 2. So du would be equal to 2 dx. And then finally, on the substitution, you're going to use, just get rid of that dx right there. So move the 2 to this side, and you get 1/2 du is equal to dx. So this matches up with this dx, and that's going to be your u substitution right there. So now we'll go ahead and rewrite this problem. So this will turn into minus the integral of the cosine of u, and then dx will turn into 1/2 du. So it looks like that. Now we can leave this part of it alone. So we've got 1/2 of x. Now again, we'll take this 1/2 and bring it out in front. So that'll be a minus 1/2 of the integral of the cosine of u and then du right here. Okay, so that's going to give you 1/2 of, and we'll leave this x alone for right now. Then you've got minus 1/2, and then just a reminder, the integral of the cosine is equal to the sine. So this will turn into the sine of u, and then you'll attach a plus c onto that. Okay, and we're almost done with this now. Next step, go ahead and distribute this 1/2, so multiply times that and times that. So you'll have 1/2 of, so this will be 1/2 of x. Then you've got 1/2 times 1/2, which will be minus 1/4, and you'll have the sine. And then inside here, we'll replace u with what it's equal to. So u will turn back into 2x. Then you'll have a plus c, and you'd be done. So there's that one right here. So really, as long as it's just a simple x right here, then it's just a matter of turning the sine squared into its formula. So you turn the sine squared into its double or half angle formula, and then split it up into two integrals, solve each one separately. One of them didn't require u substitution, and one of them does require u substitution. So that's an example of one of them that involves a sine. Now let's take a look at another one that involves a cosine, and we'll change one more thing. Rather than having a simple x in here, suppose we had something more complicated than just a simple x. So the problem might look something like this. Okay, so we've got a cosine squared, but this time we've got a 4x rather than a 2x. So again, going back to your formulas, if you start on the rules, if it's a cosine squared, then you'll turn it into this formula right here. So let's go back to our problem, and we'll just go ahead and put that on the thing here. Now, the only thing you've got to be a little bit careful about is this. This rule applies as this. If you have an x, it turns into a 2x. And you might remember from your formula, from your trig days, whatever this angle is going to be twice. So if this one was a 2x, we'll go back to here. Let's see. If this one right here was a 2x, then this one over here would be a 4x. If this one was a 4x, then this one would be twice 4x, or 8x. So just remember, whatever this one is, you double this one when you put it in the formula. Well, we've got a 4x here, so we'll change it to an 8x over here. But as far as the work goes, it'll be very similar to the one that we did in the last problem. So this will turn into then the integral of, and change the cosine squared into this formula. So it would be 1/2 of 1 plus, now the only difference in the formula is this one has a plus in it. Then it'll be the cosine. And here's where you have to be just a little bit careful. If this is a 4x here, you're going to put an 8x over here. So you double whatever it is. So on this problem, you're going to want to put an 8x right there, dx. We'll put one more parentheses around this. So now it's just a matter of solving this. So first of all, we'll do it almost exactly like we did that last one. First of all, bring the 1/2 out in front, which gets you to 1 plus the cosine of 8x dx. Now again, here's two separate integrals, so we'll go ahead and split that up. There are two separate things within one integral. So we'll split this up into the integral of 1 dx plus the integral of the cosine of 8x dx. Now again, the first one does not require u substitution. It's exactly like it was in that last problem. So we'll make this be 1/2 of, and the integral of 1 dx just turns into an x. But again, like on that last problem, since this is something more complicated than just a simple x, we're going to have to use a u substitution on this one. So we'll come over here and we'll let u be equal to 8x. And then that means that the derivative of u with respect to x would be equal to 8. So du would be equal to 8 dx. And again, we're going to want to replace this dx right here. So we'll move the 8 over here and get 1/8 du would be equal to dx. So now this matches up with this, and there's your substitution right there. So you replace it with a 1/8 du. So now back to our problem. So what we'll have is plus, and this will become the integral of the cosine of u and we'll replace the dx with a 1/8 du. Okay, next up, go ahead and bring this 1/8 out in front, which would give you 1/2 of, here's the x, plus, and we'll bring the 1/8 out here, and you'll have the integral of the cosine of u, and then you'll have du. Okay, now just to find that cosine, integral of the cosine, this is going to be 1/2 of, here is x, plus 1/8. Now remember, the integral of the cosine is the sine of u. And then remember to attach a plus c. And now it's just a matter of distributing this 1/2 and replacing the u with what it's equal to for the final step. So first of all, we'll multiply this through, and you would get 1/2 of x plus, and then a half times an eighth would be a 1/16. And then you'll have the sine of, now it's the sine of u, but u is equal to 8x, so we'll replace that with an 8x here. Add the plus c, and you'll be done. So really, the two problems follow pretty much the same format. Just split them up into the formula, and then just be careful of the fact, as long as if it's just a simple x, you can use the original formula. But if you've got a 4x here, then you have to use an 8x when you run through the thing. So there's a couple of examples where you just make a single substitution to solve the problem. And we'll do one more in the next video that also uses even powers, but we'll find an integral to a higher power where you have to do a little bit more work on it.